Greetings. I want to look at a system of linear equations where we have three equations and three variables and solving this. And we are going to begin with the elimination, and we're going to talk through how we decide to do elimination. One of the things may be that you're given instructions to do elimination. Another thing is you may look at a system of linear equations and see a quick way to do elimination. One thing to do with searching for elimination is to go through term by term and look for things that are going to be easy to subtract from each other. You're looking for the coefficients that match but have opposite signs. When we look at the first two equations here, we see we have x and 2x. The coefficient for this x is going to be 1, so we don't have matching coefficients. The next set, we have 3 and 2. There's a subtraction here, so this is going to be negative 3 and 2. Again, they don't match. Here we have z and we have negative z. We have something that matches but with opposite signs. So if we add the first equation and the second equation together, this z is going to go away because you're going to do positive 1 minus 1 is equal to 0. And so that elimination occurs. You should always do that type of an analysis if you're looking for elimination. You're looking for things that will be compatible. If you look at these bottom two, something that you could do if you were looking for elimination here, you might notice that nothing really matches for the elimination process, but you could multiply this line by a 2 and get a negative 2 here and a positive 2 here for an elimination. And the same thing occurs over here. If I had multiplied this line by 2, this would have given me a positive 4 here and a negative 4 here, and that would eliminate. And in fact, that's probably a great strategy for us to go with, because we would eliminate both the y and the z here, and that would allow us to solve for x fairly quickly. So that's the first thing that I'm going to do. I'm going to come in here and I'm going to multiply this second equation by 2. And that's going to give me 4x plus 4y minus 2z equals 8. And then the second one we are going to use as is. We're going to keep it 5x minus 4y plus 2z equals 9. And we're going to do the addition on this. So we're going to go by columns and add. So 4 plus 5 is 9x. 4 minus 4 is 0. Negative 2 plus 2 is 0. 8 plus 9 is going to give us 17. So now I have 9x equals 17. So this is going to be a simple division. Here I divide both sides by 9. And so x is going to be 17 ninths. This is not a reducible fraction, so this is the x term that we're looking for. Going back to what we had before, we can go in here and eliminate a z on the top two, because we can just add those two together. And so that's what I'm going to look at next. Okay, I'm just looking at the top two equations from our linear system. I've copied them over to the side so that I can add columns. So I'm just adding columns here. This is the x from before. I've just left it on the board so that we can use it when we need it. So we had 1 here that was there was a 1 there that you may not have seen that was hanging out. So we have 1 plus 2 is 3x. Negative 3 plus 2 is negative 1. We're just going to put the negative y there. Z minus z is 0. And 2 plus 4 is 6. So we have this equation here. We have two unknowns here, but we already solved for x. So we're going to substitute this in for x. So that's going to allow us to solve for y. When we do these systems of linear equations, we have to do a lot of side work to solve for x, y, and z, or whatever your three variables are or more. And so we're going to use this equation that we just found by adding the first two and substituting in the term that we found by adding the second two. And we're substituting that into this equation. All right, to help us out, I added a set of parentheses here. We're going to multiply 3 times the 17/9 that we substituted in for x, subtract y, and that equals 6. So we want to solve for y. So the first thing that we could do is multiply here. Order of operations tells us we should multiply before we add and subtract. And so 3 times 17/9 is going to give us 17/3. So we're going to get 17/3 minus y equals 6. So if you're not sure about that, you can check that on your calculator. I want to get this 17/3 to the other side, so since this is positive, I'm going to subtract 17/3 from both sides. And so I'm going to have this, and now you're going to have to apply some properties of fractions here. If I have a whole number here, I can set this on top of 1. And so now I have two fractions. I need common denominators since I'm subtracting. And so I'm going to multiply the top and bottom by 3 here. So 3 times 6 is 18. So I'm looking at 18/3 minus 17/3. That's going to give me 1/3. I have negative y here is going to equal 1/3. And then we can't leave this as a negative y, so we multiply both sides by a negative, leaving us with a positive y equals negative 1/3. So now we have our x and our y. Pick any of your 3 original equations that are your favorite, and you substitute these values in. I'm going to just substitute into my top equation here. It looks like it's going to be the easiest to use. So I'm going to, into here, substitute the x and the y that I just found. So my x was 17/9, and I'm going to subtract 3 times the y value that I just found. This is 1/3 negative, and z is what I don't know. That's going to be our only unknown at this point, and all of this is going to equal 2. So I've just taken this top line, substituted in the x that I found, the y that I found, and z is my unknown. If I solve this, I will have the ordered triple that I need to make this true for each equation. And so we're just going to run through this. Negative 3 times negative 1/3 is going to give us a positive 1. So that's very convenient for us. So we have 17/9 plus 1 plus z equals 2. So now we have to add 1 plus a fraction. 1 is great for creating fractions because you can just make it whatever you need it to be. In this case, I need a denominator of 9, so I'm going to make this 9/9. So I have 17/9 plus 9/9 plus z equals 2. So we're going to do this addition here. So I'm going to get 26/9 plus z equals 2. Now I need z by itself, so I'm going to subtract the 26/9 from both sides. Going through the arithmetic again, dealing with fractions, we're going to do something similar that we've already done before, looking for common denominators and working this out. I get z equals 8/9. So we're looking at a solution for this being the ordered triple of x, y, and z. All right, so that's our ordered triple. What this tells us is that if you set these x, y, and z into any of these 3 equations, it will make a true statement. If we carry out the arithmetic, we are going to get the values listed on the right where it says equals something. So that works for all three equations. We used all three of these equations to determine this ordered triple, and this ordered triple will make any of the three true. So let's go through and let's check at least one of these to make sure that we can convince ourselves that this is in fact the solution that we were looking for. I've looked at taking this third equation here, I've brought it over to here, and I've substituted in the x, y, and z from our ordered triple, and we're going to run through the arithmetic here and see if we can get a true statement. So there's a lot of fractions here, and I know not everybody likes dealing with that, but fractions, those are a valid type of number. So simplification, we have to do the multiplication first by order of operations, then we can do our addition and subtractions. So the first thing we've got to do is multiply all of these coefficients by these what are now fractions. So 5 times 17 divided by 9, it's not going to be a reducible fraction. This isn't going to come out reducible, and this is not going to come out reducible. We have a sign change that occurs here because we have a negative times negative, we get a positive. We have positive times negative here, so that gives us a negative here. The good thing about these fractions is that we can use 9 as a common denominator to do our addition and subtraction. The only thing that we have to change is this middle term. We need to multiply the top and bottom by 3 to make sure that we have a common denominator here. So that's what we're going to do next, is we're going to make this 12 ninths. So we'll have 85 ninths plus 12 ninths minus 16 ninths equals 9. And so the next thing I want to do is, going from left to right, I'm going to add these two together, and then I'm going to subtract this term here. So I have 85 plus 12, so we're going to have 97 ninths minus 16 ninths. And so there's 9. 97 minus 16 is going to give us 81 on 9, and that equals 9. And then we divide 81 by 9, we get 9 equals 9. And so we have demonstrated that choosing this equation gave us a correct answer. If you wanted to be very thorough, you could go back through and check these others as well, but we've demonstrated with this example that we have found a correct solution. Cheerful calculations.